All right, guys, I'm going to go ahead and get started on today's lecture. So, you guys have gotten introduced to arrays yesterday. And so, we're just going to continue on with this data structure because it's really important and it's used very heavily in all applications. It has a lot of use cases. And it's a way to store a list, and we're always dealing with lists and websites. And so, it's important to know a lot about this data structure and work with it um, frequently as well. So we'll dive a little bit more into arrays and also nested arrays. So I'll explain more about nested arrays, but they're popular for like interview questions, and they can represent certain things as well. You can represent like, for example, like a Excel spreadsheet or something, anything two-dimensional with nested arrays, so they can be practical. And so we'll go into arrays. Um, and so I kind of also want to touch upon a concept called immutability and mutability. Um, and this is the first slide, and it teaches us about the splice method. But to be honest, like I don't use it too much because it mutates the array. So usually what that means is like if you call splice on this array, then it'll actually change this array. Like it doesn't give you like you guys may have used slice. I'm not sure if you guys did slice, but if you use slice, then it'll basically return a whole new array. It won't affect this one. But if you use splice, then it will affect this one, and that's kind of it can lead to like a lot of confusion because like you expect this to just be a new array, but you've actually now changed this one, and so anything else, any other function that like looks at this array, now that is looking at a different array, so it can lead to like confusion in the code. So I'm not saying don't use this because this has some important like features and stuff, but you can do anything that Splice can with Slice. I would just err towards Slice just because you don't really want to be updating this when you're trying to get a subset of it or something, just because any other function that references that array, now that is looking at a different, it has like all these side effects if you mutate data structures like arrays or objects. That has like side effects down the line. Like some other function that's looking at this might be like, oh crap, like I thought this was the array. Like we declared it as this array, so why would I think that this array is different in any way? But it actually, you changed it in a different function, and now it's actually different. And so that can lead to a lot of confusion. So, but you know, this method still is like pretty. I mean, I don't really use it, but I guess it could be useful in certain ways. But yeah, it mutates the original array, and um, yeah, the concept of mutations, it only really applies to arrays and objects because you can change them, whereas in a string, you can't mutate a string. Like you just have to create a new one, but you couldn't like update um, like an existing string, like you that string or numbers, for example. Like you can't update a number, you just create a new one, which is like really safe because everything else that references that number, you know that value. Like let's say you say um, let total equals 100, then any other function that looks at total or uses total in any way, you know that it's 100 because nothing can change that value. But for arrays and objects, they're mutable, which means you can change them. And so I'm doing a lot of talking without examples, but I'll get into some examples in a bit. Um, but yeah, this splice method mutates the original array. So basically, when you do splice, you have your index that you start at, and then however many you want to remove from that index. So this one goes from 0, 1, and then it removes 1, so it should cut Thomas off the end. So when you console log names, actually it cuts. So George, I guess it cuts this element. Starting at this element, it cuts that. So if you had 2, then it would start at 1, and then it would cut this, and then it would cut that. So right now we're only cutting 1, so it just removes John. But again, like I would rather, instead of doing this, I would do like slice this one and slice this one, and then combine those if you want that, so that you don't affect this original array. That's just my own like style, just so that, again, I don't want to harp on this too much, but if you change this array, like it like might cause confusion down the road. So we're gonna go over splice again. This, now that you have 2, it starts here and then it drops this one and this one. So you get Paul and Ringo, because this is however many elements you want to kick out of that. So the original array, you remove these 2 middle elements, and then this one is the remaining. This is the array that gets created from the dropped elements. But you can do anything that splice can with slice. You can also add something else as well. But again, I don't really see much splice used in code bases, and because it mutates things, and once you start building apps, like a lot of people will stress like immutable, like don't change something, make a copy of it so that anything else that references it doesn't have a side effect of it being changed. I'll give a quick example of that. So let me just go to REPL, open this guy up, zoom in. So let's say I had like clothes, an array of clothes, and I had a t-shirt and sandals and a hat. And then let's say I had a function called like it's just called like show me clothes or get clothes. And this just returns clothes. Or let me just log it actually. And then let me have a function called like splice clothes. And then this does like let splice equals clothes dot splice. This is kind of why I wouldn't use splice. And then I don't know, like return spliced or something. So when you call get clothes, like, and you see this, when you call this, you expect to see this array, right? Because we've defined it like this, we've declared it, and like for our cases, like in this function, close, get close, we expect close to be this array, like, but like let's say somebody used this function, because this function might be in like a different file, for example, because you have all these different files, and so somebody else uses this function like somewhere else in your code, like somewhere else in your program, like this gets run, like splice close. So now you're like, now when you run get close, like you're kind of confused, because you're like, wait, in the code it says this, but now I'm logging this. Like, where did this happen? And obviously you can tell right now because it's happening in this file that this spliced close was called. So you can tell. But like in a real code base, like this function might be called some other random file that you don't know about. And so now, like, you might not even see this, but then, like, you call get close expecting that your close array is what was declared. And you should always, like, that's a great assumption. Like, it's clean, it's simple. Like, this is my array, this is what I'm working with, and in my function, I'm going to work with that array. But if you use splice, like, kind of ruins that because now some other function in your code called this function, and now you have a different array. So that's just an example of why you might not want to mutate arrays.
In the splice close function,
Yeah.
if you said let splice equal close, and then in the new line said splice spliced, or like splice dot splice 1 1, would that change the original close array, or would that just change the new copy splice?
Oh, you mean like if you say let copy equals close?
Yeah.
So I think it'll still change it because this, I believe, still points at the same address in memory. Let me try it, but I think it'll still change it, but there's a way you can get around it. So like that's a great question though, because you might want to do something like this, but maybe you don't want to change it. So how can you like avoid that? Let me just try it though. But I think it still changes it. Yeah, it still changes it. So because this address, this still points at the same place in memory, like close and copy are essentially pointing at the same thing, same place in memory. So if you want it, but that's a great point because what if I want to use splice, but I don't want to mutate the original array because someone else down the line is going to get confused now because I like if you wrote code like this, like people would be like, you know, why are you changing that array? So you would just do something like slice. So now you made a copy of close. This is an actual copy, I think. So this I think would be fine. Yeah, you still have your original array. Because like you should always work with copies and you should never mutate the actual array. But here you're mutating copy still, but like it's kind of fine because it's like contained within this function. So like, yeah, it's kind of, you're still mutating this array because that's what splice does, but it's a little more contained. Whereas here you're like affecting something that other functions look at, and you probably don't want to do that. But yeah, that's a good point. If you wanted to be clean with it, I would always recommend like slicing your array just so that now you're working with an actual copy. That's not going to have any side effects. Mm-hmm.
So I guess I'm a little confused. Like I thought that if you made a copy of something and you modified that copy, you're not modifying.
Yeah,
the original.
you're not modifying you're not modifying the original because the original is this.
Yeah.
And so you didn't modify the original because it.
Okay, you returned splice.
Oh no! Like I'm not even caring about this value at all, really. Like it doesn't even have to exist, the return value, but it's more so like this close value. Like I'm checking that this isn't changed. Like if I didn't do the slice, then shit. If I didn't do the slice, then I'm changing my original array. When I splice it, I'm changing my original array. So any other function that references this array is now just discombobulated because like when you're writing this function, you might write it with the expectation that like this is your array, you know, like that nothing else is changing that array. But now if you have other functions that change this array, now you're discombobulated because like if you do something like you know let hat equals close at or index 2, like you can't even do this anymore. This will break because you ran a function that removed this middle thing. So now index of 2 doesn't even exist, you know? But you expected it to exist because that's how it was declared, and you have no reason to think otherwise. So yeah, like stuff like this, like when you write code dependent on expecting this to be this value and then it's not, it's a little discombobulating, and so that's why we want to avoid using splice directly. I mean, you can still use it. I just don't see this like very frequently, like this splice. And if you do want to use splice, like I would recommend like you first like copying the array so that you're not actually affecting the original array that you're working with by using slice. Are there any other questions? This is just something that I've encountered a lot. Is like I mutate something, and now in another function I expect that object or that array to be a certain structure, and it's not. And like I have no way of knowing what changed it. Feel free to ask any more questions about this topic. I think it's pretty important topic to have in the back of your mind. Like just for right now, it may not be as applicable, but later on down the line. So here in splice, you don't remove any elements. You just kind of add to the existing array. So yeah, you basically, this index is where you start adding or removing. And if you put 0 here, that means you're not removing any. And then these you're just adding on to this index. Join is something that's pretty commonly used. And so what join does is it basically stringifies all your elements to a string. And so it's a shortcut. I mean, we could just use a for loop and then just like loop over each element and then like add it together in a string, like use the plus sign and just add each element to each other. But doing join is like a shortcut where it just kind of handles that for you. But we've had experience with like implementing the actual lower level like implementation of these functions that are already written. But you could imagine that it might work in some similar way. So yeah, it just returns a string. And so this becomes really powerful if you want to repetitively add like a what's it called? I'm forgetting my like grammar, but like like if you wanted to use an and to like separate all these together. So that's like the next example I think is I forget what this is called. Like I think it's con something, but like what is it? Yeah, conjunction. That's the word that I was forgetting. Thank you. But yeah, like if you wanted to add something, then this will add and to the middle of each of these elements. So it's not gonna do it at the first index. I mean the 0th index. It's not gonna add one here, but it's gonna skip the 0th index, and it's gonna add one in between the 0th and first, in between this, in between this. And I think it's gonna skip the end too. So it skips these two, and it just adds the conjunction into these. So yeah, it's like a nice shortcut if you wanted to turn an array into a string for any reason. In concat, it's like combining two arrays. So I don't think you can add arrays using plus. Like I think you can do that with strings to just use a plus sign and then it'll concat two strings together, but I don't think you can do that with arrays. So if you wanted to combine two arrays, then you would use concat. And again, this is really, concat is used a lot. There's no downside to really using it because it doesn't change the array on which it was called, which means, you know, it doesn't mutate the array. And so it's a good way to combine, like if you wanted to make this into a really long array with Ringo, John, Paul, and George all into one array, then you see all together now has these two combined like this, and then the older is still this. Like it doesn't change any of the existing arrays, which is good. Like you always want to leave the original arrays with the original values. Nested arrays. This is where it gets confusing. But arrays can really contain anything you want, so it could get as nested as you want. It's like a somewhat of a common interview question is like, yeah, like there's this nested array, like can we flatten it? Um, so yeah, this is an example of a nested array. It's an array of arrays, and you can get as deep as you like. Um, so yeah, if you want to access, so like this would be like accessing like double access where you know, the first one will give you access to this element. And then if you wanted to access elements within that, then you just keep adding brackets. And the more layers you have, you can just keep adding more and more brackets to add to access certain elements. So yeah, those are nested arrays. And right now we're only going to really consider one level, but you can kind of see how this can be a little confusing to do iteratively, because let's say like we can, with this for loop, we can say that like we can flatten a nested array nested by one level, because you have our for loop that goes through each element, and then we check, is that element an array itself? If it is, then we loop through that element to really loop through each flattened element in this nested array structure. But you could imagine like, what if I didn't know how many levels it was? Then like you can't keep indefinitely writing for loops nested within each other. So that's when like you kind of get into recursion, and we'll go over that at a later point. But I think that's like the only, because usually you can solve any problem iteratively using for loops that you can use using recursion. But I think this is one of those problems where if you don't know how many layers deep it is, then you kind of have to use recursion. I may be wrong, but otherwise you won't really know how many for loops to write. But yeah, if you for now we'll just think like two layers max. And so yeah, usually you want to like every time you write a for loop and you're iterating through, you kind of want to set, you don't have to do this. Like they could have just done if array is array at RSVP groups I, you know? Like they didn't even have to set this variable, but it's always good to do this just to like make this somewhat meaningful, because like this doesn't like, if you, I mean, element is pretty vague, but like usually you want to kind of set a variable at each level to like keep yourself grounded, as opposed to like constantly just using like, because now in this deeper level you're gonna have to use I square j, and then like if you have to go one deeper you're gonna use another, and that gets a little unwieldy. So it's nice to just have setting this variable here so that within this inner for loop you can just reference element j and just keep everything like with one square bracket, as opposed to like constantly adding on more. That's just like a style preference that I think helps your code look a little more clear. Just like declaring variables at each step of the way, even though it seems like an extra step, it can actually make things a little clearer down the line. Yeah. It's pretty much I mean that's nested arrays. So one practical application of this is to represent a two-dimensional structure. So you can think of a nested array as a grid, or like an Excel spreadsheet or something that has an X and Y coordinate, so that these could be like rows, and then these could be columns. So it can represent like a matrix. And so like, you know, like this could be like a cell in your Excel spreadsheet. And then like if you wanted to access it, you would need two you would need the x coordinate and the y coordinate, and then you could access this just based on those two. So if you did like grid 0, 0, then you access this cell. Grid 0, 1, then you access this cell. Grid 0, 2, you access this cell. So it's like an abstraction of a 2D structure, and yeah, that's why that might be like a practical application of grids, of nested arrays actually. So yeah, that's how you would represent a column, because this is the column 1, 1, 1, and so this item would be 0, 0, and then this item would be 1, 0, and this item would be 2, 0, and that's like one column right there. We're almost done with this lecture. It's kind of, yeah.
Sorry, this may not be relevant right now, but if you were going to have that, like if you were in a console log grid, how could you get it to write it on separate lines? Would you have to write a larger thing for that, or is there a way to do that?
What do you mean by writing it on a
Like if you're in a console log
grid? Uh-huh.
and you wanted it to show like the first element, the second element, the third element on separate lines, is there an easy way to do that, or would you just?
I think you can use. Let me think. You wanted to log them on separate lines.
Sorry, it's not super relevant.
Yeah, no, it's definitely like at the end of the lecture, which is like the next slide. Like I'll try it out, but I'm not too sure actually. Yeah, I know that there's like a new line character, but that's for strings.
I was just wondering if there was some kind of arrays.
Yeah, I'm not 100% sure actually about that, but that's a good question. So yeah, we're pretty much through this lecture. I mean, it's just more like a good way to really reinforce these things is just work with them a lot, work with arrays a lot, and do problems. So yeah, this is pretty much the lecture. Like, there's also a project, I believe, that's a Sudoku project, and so there's an extra workshop available, and if you guys have the time and want to look into it, then feel free to do so. It's pretty challenging, I would say, but it's like 2D arrays. It's like nested arrays that represent like a Sudoku board, and so it'll really strengthen like your comfort level with working with arrays. But yeah, are there any questions about arrays? All right, so if not, then we will get started on the problems. I think for this time around, like, I'm just gonna go over like probably like 4 at a time. I think there's 8. So like I'll give you guys some time to look over it, and you guys can ask questions while you guys work with your partner, and then I'll just go over them in like bursts. So like one burst, and there'll be another burst at the end of today. And yeah, that'll be pretty much it. Like, feel free to ask any questions. And yep.